open Gaussian that we installed along with Gaussian 2009. Now I open the optimized geometry of tetrazoltheon. And also the thiol. Just check out both the structure. This is our reactant and product. Similarly, you can also try for your reactant and product. Keep both of them opened. Now check out the numbering and labeling of the atom in both the cases. The numbering is supposed to be same for the reactant and the product. If it doesn't match, we may not end up with the transition state what we wish to attain. See here, the numbering and labeling doesn't match. So, we are going to change the numbering for this hydrogen atom. This is very important proton. This particular proton, the 11th proton, is going to be transferred from 6th sulfur atom to 5th nitrogen atom. For editing it, go to the add-on menu and click on the atom list. Now I am changing this 8th atom to 11th one. The rest got automatically changed. Now close it and go to the structure. Atom label is changed. So, the reactant and the product has the same numbering now. So, we can now go to the next step. Leave these windows opened, go to the Gauss View add-on menu, then click on the File New Create Molecule Group. Now, copy the structure of reactant and paste Add to Molecule Group. Copy the structure of product and paste Add to Molecule Group. The input file has now two structures, the reactant and the product. Now we are going search the transition state for this proton transfer, that is, the thiol-thione tautomerism. Click on Calculate Gaussian Calculation Setup to set it up as per our requirement. Set the job type Opt plus Frec. To carry out the optimization followed by the frequency calculation. Optimization to A. TS, QSD2, that is transition state. Calculate force constant once. If it doesn't work, change it to always. The rest let it to be default. Click on the method to choose the method. Choosing method based on your requirement. I have done the calculation using DFTB3 lip 6-31 Thorn G, D, level. This is the basis set I have chose. But it takes quite long time. The calculation took nearly 3 hours. So, I am showing the calculation using AM1 method. That takes less than 5 minutes. It also gives the result. However, the result may not be very accurate. A basis set in theoretical and computational chemistry is a set of functions, called basis functions, that is used to represent the electronic wave function in the Hartree-Fock method or density functional theory. The basis set can either be composed of atomic orbitals, yielding the linear combination of atomic orbitals approach, which is the usual choice within the quantum chemistry community, or plane waves, which are typically used within the solid-state community. Several types of atomic orbitals can be used: Gaussian type orbitals, Slater type orbitals, or numerical atomic orbitals. Out of the three, Gaussian type orbitals are by far the most often used, as they allow efficient implementations of post-Hartree-Fock methods. Here we are going to choose semi-empirical method default spin AM1 method. Give job title here. TS calculation for tetrazole. The rest can be left default. Now submit the job and wait for some time for the completion. This calculation took only 2 minutes for completion. The timing is shown here. Now let us click on Yes. Go to the Gauss View add-on menu, open the .log file. This is our transition state structure. We need to check whether we arrive at the right structure or not. That can be done by clicking Results. Click on Vibrations. Check the first frequency. Yes, it is negative frequency. If it is negative, it means it is imaginary. That confirms that we arrived at the right structure, that is right transition state. Look at the structure in animation mode. Yes, this is what we expected. The transfer of proton from sulfur atom to the nitrogen atom, happening very nicely. So finally we arrived at the transition state. This is how we can find out the transition state for any reactions. See, I have also plotted the energies of optimized geometries of reactant, product and the transition state. So, we carried out the calculation for this conversion. I have plotted the graph for the relative energies that is tabulated here. Okay, if you have any queries related to this calculations you can write to me. I am ready to answer. Thank you all for your attention.